Hi friends, welcome back to C-Level Physics. My name is Srinivas, known to be BS Rao. In this video, we are going to discuss subtraction of vectors. Before that, we need to discuss some characteristics of addition of vectors. What are the means? First one, if A bar, B bar are two vectors, then A bar plus B bar is equal to B bar plus A bar. In the sense, adding B bar to A bar is equal to adding A bar to B bar, both one and the same. So if two vectors are added such that A bar plus B bar equal B bar plus A bar, then it is said to be commutative law. So vector addition obeys commutative law. Coming to next property, if A bar, B bar and C bar are three vectors, then B bar plus C bar gives one vector which is added to A bar. Here B bar is added to A bar, resulting one vector to which C bar is added. In both cases, we will have same result. So that property is said to be associative law. So vector addition obeys associative law also. Coming to third property, distributive law. What is that? If A bar and B bar are two vectors and K is any constant, then K into A bar plus B bar equal to K A bar plus KB bar means distributive law. So vector addition obeys distributive with respect to one scalar constant, that is K into A bar plus K into B bar, also equal to K of A bar plus B bar. Now coming to one numerical, that is if A bar plus B bar plus C bar is 0 bar, that is null vector, and A is 1, B is 2 and C is 3, find the angle between A bar and B bar. What is the angle between A bar and B bar? Let us see. From data, A bar plus B bar plus C bar equal 0 bar, null vector. Make it such that A bar plus B bar, that is A bar plus B bar equal to minus of C bar, that is make it reverse, minus C bar equal to A bar plus B bar. Okay, so the resultant of A bar and B bar is equal to minus C bar. Take magnitude of minus C bar by using parallel law of addition of vectors, that is mod of minus C bar is equal to mod of A bar plus B bar, that is equal to square root of A bar plus B bar and are modulus, in the sense the magnitude of resultant of A bar and B bar, that is A square plus B square plus 2AB cos theta. So mod of minus C bar in the sense C1. Why? Because modulus always gives positive value. That is, mod of minus C bar means C only. C equal to root over A square plus B square plus 2AB cos theta. On squaring both sides, C square equal to A square plus B square plus 2AB cos theta. 2AB cos theta. Now, C square minus A square minus B square equal to 2AB cos theta. That is, cos theta equal to C square minus A square minus B square by 2AB. Okay. Now what is C square? C means 3. C square in the sense 9. That is 9 minus, what is A square? That is 1 square. Means 1 minus B square. What is B square? 2 square. That is 4. Divided by 2 into A means what? 1. B means what? 2. Okay. So cos theta equal to 9 minus 5. That is 4. Divided by 2 to the 4. That is 1. Cos theta equal to 4 by 4, that is 1. Theta equal to cos theta 1 means theta equal to 0 degrees. Theta means angle between A bar and B bar. Angle between A bar and B bar. Why? Because A bar plus B bar equal minus C bar. So we came across the magnitude of resultant of A bar plus B bar. That is theta in the sense angle between A bar and B bar. Theta 0 in the sense A and B are parallel to each other. That is A bar is parallel to B bar. Okay, A bar is parallel to B bar. Now, coming to subtraction of vectors. Subtraction of vectors in the sense Subtraction. How to subtract given vectors? How to subtract given vectors? Let us see. Suppose P bar and Q bar are two vectors. With theta is the angle between them, as shown. Let us see subtraction vectors. Subtraction of vectors. Okay. Now see, two vectors are there here. Right. So this is what P bar, this is what Q bar. Now what is the angle between these two vectors? Theta. Okay, theta is the angle between parent vectors. These two are drawn from the same point. I am taking both as adjacent sides of parallelogram. Now parallelogram in the sense it should have four sides. Now where are the other two sides means parallel to P bar, take one side somewhere here. Parallel to Q bar, take one more side somewhere here. Right? Like that. Okay. Now what is P bar plus Q bar here? Diagonal drawn from the intersection of P bar and Q bar is the resultant. This is what resultant. So R bar equal to P bar plus Q bar. R bar equal to P bar plus Q bar. This is what the sum of P bar and Q bar. Otherwise resultant of P bar and Q bar. Now angle made by resultant with P bar is, let it be alpha 1. Alpha 1. Right? Alpha 1. This is what let me say alpha 1. This is what P bar. Okay. Right? Now here R bar equal to P bar plus Q bar. Now mod R bar equal to R equal to square root of P square plus Q square plus 2PQ cos theta from parallelogram of addition of vectors. Right? Now what is the tan alpha 1 here? To get tan alpha, suppose this is O, this is what A, this is what B, this is what C. Now I am taking normal drawn from end C onto P bar like that. This is what normal drawn onto P bar. I am extending this one like that. So this is what 90 degrees. As it is Q bar, the measurement is Q here. Here also Q over. So Q. Now this is what theta between P bar and Q bar. Here also theta. Why? Because these two are corresponding angles. Right? Now this is what opposite side with respect to Q here. That is with respect to theta, this is opposite side. Hence Q sin theta. This side is Q sin theta. Suppose this is what D. Q sin theta. Q sin theta. Now this measurement is Q cos theta. Q cos theta. AD is Q cos theta. CD is Q sin theta. Okay. Right. So from this right angle triangle, tan alpha 1 equal to opposite side by adjacent side. See, from right angle triangle ODC with respect to alpha 1, CD is the opposite side and OD is the adjacent side. So tan alpha 1 equal to opposite side Q sin theta by adjacent side P plus Q cos theta. P plus Q cos theta. Right? This is number 1. This is number 2. So this is what already we have come across addition of vectors. Means this is addition of vectors only, not subtraction of vectors. Now let us see subtraction of vectors. In the sense, I want to get P bar minus Q bar. P bar minus Q bar. What is P bar minus Q bar here? P bar minus Q bar. How to get P bar minus Q bar? Means vector P bar minus vector Q bar. That is what subtraction vectors. It can be written as P bar plus or minus Q bar. Plus or minus Q bar only. Means adding minus Q bar to P bar. That itself P bar minus Q bar. Means That means to say that there is no separate subtraction in case of vectors. So subtraction vectors also some kind of additional vectors. So that is adding minus q bar to p bar, that itself p bar minus q bar. So there is no separate vector subtraction. Okay. So subtraction in case of vectors in the sense adding negative vector to given vector, that itself subtraction of vectors. Okay. So our task is to add minus q bar to p bar. See, this is what p bar. How to get minus q bar is simply make it reverse q bar here, end to end. So this is what tail, this is what head. If it is make it reverse, we will get minus q bar like that. This is what minus q bar. So same magnitude, that is same length, here also same length as an example, but direction is altered, reversed, that is minus q bar. So if it is q bar, OB is q bar, some kind of OE bar is minus q bar. Okay. Now, if theta is angle between p bar and q bar, now what is angle between p bar and minus q bar? Means 180 minus theta. Why? Because this is theta, this is what 180 minus theta. Why? Because straight line makes 180 degrees. So if this is theta, remaining angle is 180 minus theta. So now angle between p bar and minus q bar is 180 minus theta. 180 minus theta. Now simply here p bar and minus q bar are drawn from the same point and are taken as the adjacent sides of parallelogram. These two are adjacent sides of parallelogram drawn from the same point O. Right? Now close the parallelogram to get remaining two sides also. Means here we have two sides. Close this parallelogram like that. Parallel to p bar one side here. Parallel to minus q bar one more side here. One more side. Alright. So this is what F O E F A is the parallel, new parallel. Okay. Now parent vectors are p bar and minus q bar drawn from point O. Now diagonal drawn from the intersection of p bar and minus q bar means from this O. Diagonal drawn from the intersection of p bar and minus q bar gives the resultant of these two vectors. Means this is what diagonal drawn from the intersection point. Okay. Now this is what is it sum or difference? This is what sum means resultant of p bar and q bar. Now this is also a kind of resultant only, but p bar minus q bar here. P bar plus of minus q bar, that is p bar minus q bar means difference vector. That is what I am taking it as d bar. Difference, not d. These two are not same. Okay. Difference vector d bar equal to p bar plus or minus q bar, that is p bar minus q bar. P bar minus q bar. Right? Now, angle made by this difference vector with p bar, let it be alpha 2. Let it be alpha 2. Angle made by sum or resultant with p bar is alpha 1. Angle made by difference with p bar is alpha 2. Right? Here it is alpha 1, here it is alpha 2. Right? Now, from this end F, take one normal onto p bar like that. This is what normal drawn from end F onto p bar. Now it made somewhere here. So this is what 90 degrees. 90 degrees. Right? Now, if it is minus q bar, what is the measurement here? Q1. Okay, as far as vector notation is concerned, this is what minus q bar. As far as magnitude is concerned, q1. So this measurement is q. Now this measurement also q1. Q. Right? Q. Now this angle is theta. Now what about this angle? 180 minus theta. 180 minus theta. Right? So this angle is theta. Now remaining angle is 180 minus theta. Now what about this angle? That is, if it is 180 minus theta, this is what theta. So theta. Right? This is what right angle triangle. From this right angle, this is what a small right angle triangle. Okay. Now with respect to this theta, right? This is what opposite side, opposite side. This is what adjacent side, right? So this opposite side equal to, with respect to this theta, this is opposite side. Now opposite in the sense we have to consider sine theta. So here, what is this measurement means? Q sine theta. Q sine theta, right? Now this is what Q cos theta. This measurement is Q cos theta. This measurement Q cos theta. Q cos theta. So from here to there. From here to there, this small measurement is Q cos theta. Why? Because this is what Q. This becomes adjacent side. So Q cos theta. This is what opposite side with respect to theta means. This is what Q sin theta. So this measurement is Q sin theta. This measurement is Q cos theta. Right? So as far as this right angle triangle is concerned, see, this is what one right angle triangle. As far as this right angle triangle is concerned, now with respect to alpha 2, this is what opposite side, this is what adjacent side. So tan alpha 2 means opposite side by, see this right angle triangle, tan alpha 2 equal to opposite side by, okay, tan alpha 2 equal to opposite side by, what is opposite side here? Q sin theta. Q sin theta divided by, what is adjacent side? This is the adjacent side. Now from here to there, that is P. In fact, this is P bar. As far as measurement is concerned, P only. From here to there, P. From here to there, Q cos theta. So to get this measurement, how to get this measurement means P minus Q cos theta gives this measurement. So P minus Q cos theta. P minus Q cos theta gives this measurement. Okay, tan alpha 2 equal to Q sin theta by P minus Q cos theta. Now coming to this point, D bar equal to P bar minus Q bar, that is P bar plus or minus Q bar. If I take magnitude of D bar, mod D bar equal to square root of P bar plus or minus Q bar. As far as parallel law of addition is concerned, to get magnitude of resultant of two vectors is given by root over P square plus Q square plus 2PQ cos. What is the angle between P bar and minus Q bar here? This is what P bar, this is what minus Q bar. Angle between P bar and minus Q bar is 180 minus theta. That is cos 180 minus theta. Okay. Once again, difference vector. This is what sum or resultant vector. This is also one kind of resultant only. Okay. For the time being, I am calling it as difference D. D bar equal to P bar plus or minus Q bar. To get magnitude of difference vector, that equal to square root of P square plus Q square plus 2PQ cos. Up to here, common only as far as parallel law of addition is concerned. Cos of theta. Is it theta or 180 minus theta? 180 minus theta. Why? Because angle between P bar and minus Q bar. P bar and minus Q bar. Angle between P bar and minus Q bar is 180 minus theta. So replace with 180 minus theta in this expression. That is D equal to difference equal to, this is what R, this is what difference. Difference equal to square root of cos 180 minus theta means minus cos theta. That is P square plus Q square. Cos 180 minus theta means minus cos theta. Minus or plus minus 2PQ cos theta. Cos 180 minus theta means minus cos theta. So as far as sum or resultant is concerned, R equal to root over P square plus Q square plus 2PQ cos theta. As far as difference magnitude of difference vector or magnitude of subtraction of two vectors is concerned, then the difference equal to Q square plus Q square minus 2PQ cos. Here what makes the difference between these two means simply sign on. Here positive sign, here it is negative sign. Okay. This is what in case of addition of two vectors. This is what in case of subtraction of two vectors. Okay. Root over P square plus Q square minus 2PQ cos theta. Right? Cos theta. Suppose if I add these two expressions, this is what number 3, this is what number 4. So 1, 2, 3, 4. Right? So this is what root over p square plus, right, number 1, number 2, number 3, number 4. Okay. Now I am adding 2 and 4. 2 and 4. 2 plus 4. 2 plus 4 implies 2 plus 4 means tan alpha 1 plus tan alpha 2. Tan alpha 1 plus tan alpha 2 is equal to tan alpha 1 plus tan alpha 2, that is LHS plus LHS equal to RHS plus RHS. What is RHS here? Q sin theta. Q sin theta divided by P plus Q cos theta. P plus Q cos theta plus, here what is RHS? Q sin theta by P minus Q cos theta. Q sin theta by Q sin theta by P minus Q cos theta. Right? That is tan alpha 1 plus tan alpha 2 equal to Q sin theta is common here. Q sin theta. Q sin theta is common, kept common. 1 by P plus Q cos theta. Here 1 by P minus Q cos theta. What is LCM? A plus B, here it is A minus B. A plus B into A minus B. That is A square minus B square. That is A square. That is P square minus Q square cos square theta. Right? P plus Q cos theta into P minus Q cos theta. Is A square minus B square. P square minus Q square cos square theta. Coming to numerator here. Q sin theta is kept outside, that is we left with 1. 1 into P minus Q cos theta, that is P minus Q cos theta. Here Q sin theta is kept outside, that is here we left with 1 only. 1 into P plus Q cos theta, that is plus, here positive sign is there. Here 1 into P plus Q cos theta, that is P plus Q cos theta. Right? Now minus Q cos theta plus Q cos theta cancel with each other. We left with the P plus P, that is P is 2P. P plus P is 2P. So what is ultimate result? Tan alpha 1. Tan alpha 1 plus tan alpha 2 equal to P plus P, 2P into Q sin theta. Yes, 2PQ sin theta by P plus P, 2P into Q sin theta, 2PQ sin theta divided by P square minus Q square cos square theta. Okay. P square minus Q square cos square theta. So this is what tan alpha 1 plus tan alpha 2 is concerned. Right? Now if I call it as diagonal 1 and it is diagonal 2, then R bar means as far as addition is concerned, if I call it as first diagonal and here it is second diagonal. So here it is D1 bar, here it is D2 bar. So suppose in the adjacent diagram D1 bar equal to R bar equal to P bar plus Q bar. Now what is R? What is D1? D1 equal to R equal to, that is mod D1 bar, that is mod R bar equal to root over P square plus Q square plus 2PQ cos theta. That is D1 square equal to P square plus Q square plus 2PQ cos theta. That is number 1. Alright. Coming to this bottom diagram, as far as this diagonal is concerned, I am calling it as D2 bar, means diagonal 2. D2 bar equal to second diagonal as far as subtraction is concerned. Here it is addition diagonal, here it is subtraction diagonal. D2 bar is concerned. D2 bar equal to capital D bar equal to what we wrote here, that is P bar minus Q bar. P bar minus Q bar. That is D2 equal to mod D2 bar, that is D2 equal to mod D bar, that is D equal to root over P square plus Q square minus 2PQ cos theta. Now itself we have written same one, that is D1 square, here D2, here it is D2. Now I am squaring both sides, D2 square equal to P square plus Q square minus 2PQ cos theta. This is what number 2. Number 2. On adding both expressions 1 and 2 means square of diagonal of addition of these two vectors. Here square of diagonal of subtraction of these two vectors. That is D1 square plus D2 square means 1 plus 2 implies 1 plus 2 implies 1 plus 2 implies, that is D1 square plus D2 square equal to, what is D1 square? P square plus Q square plus 2PQ cos theta, 2PQ cos theta plus, what is D2 square? P square plus Q square minus 2PQ cos theta. Right? Okay, here it is plus 2PQ cos theta, here it is minus 2PQ cos theta. Both cancel with each other. We left with P square plus Q square plus P square plus Q square. So P square plus Q square is repeated twice, that is D1 square plus D2 square is equal to twice. See, P square plus Q square, here also P square plus Q square, that is repeated twice, that is 2 into P square plus Q square. Okay, so D1 square plus D2 square equal to 2 into P square plus Q square. Okay. Now, special cases in case of subtraction of vectors. So in previous class, we came across special cases in case of addition of vectors. In the same way, you can have different magnitudes of difference of two vectors with the change of angle between them. Okay, if theta is 0 degrees or if theta is 180 degrees and if theta is 90 degrees, let us see. Special cases. Special cases. Subtraction. Subtraction of vectors. Special cases of subtraction vectors. What are the special cases here? Number 1. If theta is 0 degrees. If theta is 0 means two vectors are P bar, here it is Q bar. Both are parallel to each other. We have to subtract Q bar from P bar as an example. That is D bar equal to P bar minus Q bar. P bar minus Q bar. Now what is the magnitude of difference of these two vectors? That is D. Magnitude of difference, D equal to square root of P square plus Q square minus 2PQ. As far as the difference is concerned, what is the sign we shall use here means, that is minus, negative sign. In case of addition means positive sign. In case of subtraction means negative sign. That is P square plus Q square minus 2PQ cos theta. Cos theta. What is theta between P bar and Q bar? 0, 1. So take it as 0 degrees. That is cos 0 means 1. So P square plus Q square minus 2PQ. Difference is equal to root over P square plus Q square minus 2PQ into 1. Cos 0 means 1. That is P square plus Q square minus 2PQ in the sense P minus Q whole square. That is D equal to root over P minus Q whole square. If P is greater than Q, P minus Q. If Q is greater than P, Q minus P. So that is D equal to square root to cancel. That is D equal to P difference Q. I am writing it as a difference Q. difference q. Why? Because if p is greater than q, it can be p minus q. Otherwise, q minus p. So that is the reason why I am using this sign. That is the difference. So p in the sense mod p bar, q in the sense mod q bar. Take one more modulus. One more modulus. So this is what minimum value in getting magnitude of their difference. Why? Because here negative sign is there. Cos 0 means 1, that is maximum. So we are subtracting max value here from p square plus q square under square root. Therefore, whatever we got here, that is minimum value among all possibilities. So d minimum in case of addition vectors or subtraction vectors is valid possible means when given vectors are parallel to each other. Okay, we will get minimum value, d minimum. So in case of additional vectors, if two vectors are parallel to each other, in case of additional vectors, in that case you can have maximum result, but here it is minimum result, quite opposite. Okay, as far as addition is concerned, if two vectors are parallel to each other, then we can have maximum result among all angles. But here it is minimum result for the same angle. See, result is quite opposite. Right? Now, coming to 180 degrees. 180 in the sense p bar is rightwards, q bar is leftwards. Here it is q bar, for example. So d bar equal, I want to get a difference vector, that is p bar minus q bar. So p bar minus q bar, that is d equal to magnitude of difference equal to root over p square plus q square minus 2pq cos theta. This time what is theta? Cos theta in the sense what is theta? What is the angle between p bar and q bar? 180, that is 180 degrees. Now what about cos 180? Cos 180 means minus 1. That is what? Minus 1. Minus 1. Minus or minus plus, that is plus. P plus q whole square this time. So therefore, here p plus q whole square in the sense square root cancel. We left with p plus q. That is p plus q. That is p means mod p bar plus q means mod q bar. So this time we have maximum result. Why? Because of course here cos 180 is minus 1. Least value, but minus or minus plus here. So that is how we can have maximum result, provided theta is 180 in case of subtraction vectors. Maximum result. Maximum result. Okay. Okay. For the same angle in case of addition of two vectors of the same vectors, what is the resultant? P minus q in case of additional vectors. But for the same angle, here it is p plus q only, means maximum result. So once again result is opposite with respect to addition, right? Now coming to 90 degrees. 90 degrees in the sense both are perpendicular to each other. Both are perpendicular to each other. See, both are perpendicular to each other. Suppose here it is p bar, here it is q bar as an example. Means both are perpendicular to each other. Now I want to get p bar minus q bar. P bar minus q bar means make it reverse here. This is what minus q bar. Minus q bar. P bar minus q bar. Simply make it reverse q bar to get minus q bar. So p bar minus q bar. Now take diagonal drawn from the intersection. Now this is what difference. D bar equal to p bar minus q bar. Now close the other two sides like that. Right? Now, in this case, d bar equal to p bar minus q bar once again. So, what is the magnitude of difference? That is d equal to square root of p square plus q square minus 2pq. Negative sign is there with expression only. From the formula itself, we have negative sign. So, root over p square plus q square minus 2pq cos theta. Cos theta. What is theta between given vectors? P bar, q bar, inclined at an angle 90 with each other. In fact, p bar, q bar. Here also 90 only, here also 90. That is cos 90 degrees. Now cos 90 means 0. That is d, the magnitude of difference of these two vectors, d equal to root over p square plus q square minus 2pq into cos right away 0. That is 0 and something 0. So difference equal root over p square plus q square. Root over p square plus q square. Okay. Now, what is the range of magnitude of subtraction of two vectors? Means now itself we came across. What is the maximum resultant? Means p plus q, provided theta is 180 degrees. What is the minimum resultant? Yes, that is p difference q or q difference p, provided theta is 0 degrees in case of subtraction. Now this is what intermediate value. Okay. Now I'm combining p plus q greater than or equal to difference greater than or equal to p difference q. P difference q. P means mod p bar. Q means mod q bar. Take one more mod. Why? Because difference never be means magnitude never be negative. That is the reason why I am taking one more modulus here. Okay. Right? Of course, here it is larger value minus smaller value. No need to get negative value here. So here it is maximum resultant, maximum difference. Maximum difference. Here it is minimum difference. Minimum difference. Okay. This value can be obtained when angle between given vectors is 180 degrees. 180 degrees means as far as anti-parallel vectors are concerned, we can have maximum resultant among all possible angles. As far as parallel vectors are concerned, we can have minimum resultant in case of parallel in the sense 0 degrees. Right? Okay. Whatever it is, the range of difference, magnitude of difference also same as that of addition. Of course, in case of addition also maximum resultant p plus 2, but provided theta is 0 degrees, but here it is 180. In case of addition, minimum resultant also p difference 2, but provided theta is 180, but here it is 0 degrees. Result is quite opposite, but range is same. The range of difference is same, right? So these are the special cases of subtraction of vectors. Special cases of subtraction of vectors, right? Now, what are the characteristics of subtraction of vectors? Characteristics in the sense properties. As far as addition vectors are concerned, addition vectors obeys commutative rule, but in case of subtraction vectors, do not obey commutative. See, properties of subtraction. Properties of subtraction vectors. Subtraction vectors do not obey commutative law. Subtraction vectors do not obey commutative law. That is, a bar minus b bar cannot be b bar minus a bar. See here, subtracting b bar from a bar. Here subtracting a bar from b bar. Both are not same. A bar minus b bar is not equal to b bar minus a bar. Of course, it is anti-commutative. If you take one negative sign somewhere here in front, but it is anti-commutative. Anti-commutative. It obeys anti-commutative. Do not obey commutative law, but it is anti-commutative. Hence, a bar minus b bar can be written as minus of b bar minus a bar. Why? Because take this negative sign inside, that is minus b bar minus or minus plus a bar. Minus b bar minus or minus plus a bar. That is a bar minus b bar. A bar minus b bar equal to a bar minus b bar. Once again, means it is anti-commutative. By taking negative sign in front, we can equate both. Here do not obey means not equal. Do not obey means not equal. Alright. Now coming to associative law. Number 1. Number 2. Subtraction vectors also do not obey associative. So do not obeying associative. Associative. Do not obey associative. Means if A bar, B bar and C bar are 3 vectors, that is A bar minus B bar minus C bar is not equal to A bar minus B bar minus C bar. See, B bar minus C bar resulting one vector which is to be subtracted from A bar. Okay, we can have one result left side. Similarly here, B bar is subtracted from A bar, we can have one result from which C bar is subtracted. So here LHS is not equal to RHS, means A bar minus of B bar minus C bar not equal to A bar minus B bar minus C bar. We don't have common value on both sides. That is the reason why do not obey associative as far as subtraction vectors are concerned. Coming to distributive law. Distributive number 3. Subtraction vectors obeys distributive. Obeys distributive law. Obeys distributive with respect to one constant. Suppose k is constant, k into A bar minus B bar equal to, can be written as K bar minus KB bar. If K is one scalar and A bar and B bar are 2 vectors, then can be written as K of A bar minus B bar equal to K bar minus KB bar. Here constant is a distributive. Okay, K bar minus KB bar. So as far as subtraction vectors are concerned, do not obey commutative law, but it is anti-commutative. Here also do not obey associative law, right? But obeys distributive law as shown, right? Now coming to one numerical. Regular hexagon sum, very very important. Regular hexagon. Regular hexagon. Important sum. That is A, B, C, D, E, F is a regular hexagon with O as center. O as center. Okay, A, B, C, D, E, F is a regular hexagon with O as center. Right? Now find AB bar plus AC bar, AB bar plus AC bar plus AD bar, AD bar, AD bar. I am writing here. Find AB bar plus AC bar plus AD bar plus AE bar plus AF bar. Okay. See here we have one regular hexagon A, B, C, D, E, F. Okay, with O as center. Now we need to find AB bar plus AC bar plus AD bar plus AE bar plus AF bar. Now we need to construct one regular hexagon. Okay. Now say regular hexagon means 6 sides. Right. So here it is A, B, C, D, E, F. So A, B, C, D, E, F is a regular hexagon with O as center. O as center. Right. Now we need to find AB bar plus AB bar plus AC bar plus AD bar plus AE bar plus AN bar, right? So before that I am taking two lines, extended lines from O to A and B, like that, right? I am calling it as, suppose this is R1, this is R2. In fact, these are only vectors. These are not vectors. If I take these measurements as vectors, R1 bar, here it is R2 bar. R1 bar, here it is R2 bar. Means, suppose as an example, one particle moves along this regular hexagon, right from point A to point B, again from B to C, again from C to D, again from D to E, from E to F, and finally from F to A, like that. See, this is the path followed by one particle, right? As far as AB is concerned, when particle is situated somewhere here at A, with respect to O, this is initial position vector. When the same particle reaches B, with respect to O, this is final position vector. Say AB bar is S bar. AB bar is S bar as an example. These are not given in data, but I am taking like that. See, when particle is at A, R1 bar is the initial position vector. When the same particle reaches B, R2 bar is the final position vector. Why? Because O is our origin. Okay, R1 bar, R2 bar, S bar. See, R1 bar, here S bar, here R2 bar. R2 bar. Of course, here it is O, here it is A, here it is B, right? So make it reverse the direction of any one of these vectors, make it reverse. Let us see what happens. If I make it reverse R2 bar from end to end like that, if I make it reverse R2 bar end to end like that, let us see what happens. Of course, you can make it reverse any one of these three vectors, right? I am making reversing R2 bar, that is R1 bar as it is, S bar as it is. I am making reversing R2 bar end to end. See, end to end. After making reversing, what happens? Is it R2 bar minus R2 bar? Yes, it is minus R2 bar. See, all these three vectors are joined end to end. End to end in the sense, head of one vector joined with the tail of other vector, and so on. Head to tail joined, head to tail joined, head to tail joined. Means all the three vectors taken as the sides of triangle in the same order. Means that is anti-clockwise sense. Head to tail, head to tail, head to tail. Means in that case, what is the resultant? That is 0 bar. That's what triangle of addition of vectors. Okay. So R1 bar plus S bar minus R2 bar is equal to 0 bar. See, R1 bar plus S bar plus or minus R2 bar is equal to 0 bar as far as triangle of addition is concerned. Am I right? Of course, here it is O, here it is A, here it is B. Right? See, all the three vectors are taken in the same order, head to tail, head to tail, head to tail are joined. In that case, the sum of all the three vectors is null vector. That's what I have written. R1 bar plus S bar plus of minus R2 bar is 0. That is S bar equal to S bar. Here only R2 bar, take that side, that is minus R2 bar. That side means R2 bar minus R1 bar. R1 bar. That is S bar in the sense, what is S bar in fact? AB bar. S bar in the sense AB bar. See, AB bar is the S bar. So AB bar equal to, AB bar is equal to, what is R2 bar? R2 bar means OB bar. OB bar minus, what is R1 bar? That is OA bar. R1 bar means OA bar. OA bar. So this is a basic relation, that is AB bar equal to OB bar minus OA bar. AB bar, of course this is, I am taking it as displacement vector from A to B. Then displacement vector equal to final position vector minus initial position vector with respect to fixed origin. So R2 bar minus R1 bar equal to S bar. So as far as displacement of particle from A to B is concerned, A is the initial position, B is the final position. Then R1 bar is the initial position vector, R2 bar is the final position vector. So AB bar, that is S bar, otherwise AB bar equal to final position vector minus initial position vector. As far as BC is concerned, as far as BC bar is concerned, OC bar minus OB bar. Okay. Why? Because BC bar equal to final position vector minus initial position vector with respect to. So BC bar equal to OC bar minus OB bar. Similarly, CD bar equal to OD bar minus OC bar. Similarly, DE bar equal to OE bar minus OD bar. Similarly, EF bar equal to OF bar minus OE bar. Similarly, FA bar equal to FA bar equal to FA. A means final, F means initial. So final position vector minus initial position vector and so on. Okay. Right. Now question is AB bar plus AB bar plus AB bar plus AC bar plus AD bar plus AE bar plus AF bar is equal to right. AB bar in the sense, what is AB bar? See, AB bar means OB bar minus OA bar. OB bar minus OA bar. Okay, this is completed. AB bar means OB bar minus OA bar, right? Plus AC bar. See this hexagon. AC bar. A is somewhere here, C is somewhere here. A is initial position, C is final position. AC bar, direct, see, AC bar, initial position, final position. AC bar can be written as from that relation, AC bar equal to OC bar minus OA bar. OC bar minus OA bar, right? Right. So AC bar equal to OC bar minus OA bar. Now coming to third point, that is AD bar. A is somewhere here, D is somewhere here. AD bar through origin O. AD bar means A is initial, D is final. So final position vector minus initial position vector. That is OD bar minus OA bar. OD bar minus OA bar. Minus OA bar. Plus, so this is also plus AE bar. What is AE bar? A is somewhere here, E is somewhere here. AE bar, A means initial, E means final. So final position vector minus initial position vector, that is OE minus OA. OE minus OE minus OA. OE minus OA. OE minus OA, right? Now AE bar also over. Okay, we left with AF bar. What is AF bar? A means initial, F means final. So final position vector minus initial, that is OF minus OA. OF minus OA. Right? That is, see, first term OB plus OC plus OD plus OE plus OF. That is OB bar, here OC bar, OC bar, here OD bar. I am taking positive signs. The plus OB plus OC plus OD plus OE plus OF. So OB bar plus OC bar plus OD bar plus OE bar, plus OF. This is one term. All are positive terms. We left with negative terms. That is minus OA bar, minus OA bar, minus OA bar, minus OA bar, minus OA bar. That is 5 times minus OA bar. 1, 2, 3, 4, 5. That is minus 5 times OA bar. Okay. Now see hexagon here. OB plus OC. OB, here OB, here OE also there. OB, OE. See these two. Here OB, OE. OB, OE. Equal in magnitude but opposite in direction. OB bar, OE bar are Negative vectors means both in same in magnitude, but direction is opposite to each other. That is, both cancel with each other. Okay. OB bar is negative vector to OE bar. So mutually negative vector, these two vectors. So cancel with each other. Similarly, OC, where is OC? Your OC bar, OF also there. See OC and OF. OC bar, OF bar, mutually negative vectors. OC bar, see OC bar and OF bar are same in magnitude but opposite in direction. That is the reason why both are negative vectors, means cancel with each other. Cancel with each other. Right? We left with OD bar. OD bar. That is OD bar minus of 5 into OA bar. That is OD bar means OD bar equal to minus of OA bar. OD bar and OA bar are mutually negative vectors. That is OD bar equal to minus of OA bar. That is minus of OA bar minus 5 into OA bar. That is minus 6 times OA bar. Minus of 6 times OA bar. Otherwise, 6 into minus OA bar. That is 6 into minus OA bar means this is what minus OA bar. This is what OA bar. If it is minus OA bar means minus OA bar equal to OD bar. OD bar. This is the ultimate result. So these two are mutually negative vectors. So that is the reason why we can replace minus OA bar with OD bar. So OD bar, OA bar, mutually negative vectors. That is the reason why if it make it reverse OA bar, we will get OD bar. So minus OA bar becomes equal to OD bar. That is the result. Okay, friends. Please I'm requesting all the audience to please subscribe C-level physics. Okay, thank you, friends.